So today we have this geometrical question, and I am sure that you have seen this question before also, but the method that we are going to use to solve this question is very different, and probably you are going to see it for the first time, because there are tons of video on this same question, and what they are using we all know, that is drawing the extra lines and doing the calculations. That is also a very nice way, but here we have this question and it will be solved using my method. So let us see the solution. So what we will do is first of all mark some of the missing angles using the angle sum property, and they are very simple, there is nothing to be explained in that. So we get that this angle over there is equals to 30 degree, over there the angle is equals to 20 degree, over here the angle is equals to 40 degree. If the inner side is 40 degree, by linear pair we have that this angle equals to 140 degree. Okay, all these were required things. Now what we can just observe is that this biggest triangle has its base angles as 80 degrees, 60 plus 20, 80, 70 plus 10, 80. So base angles are 80 and 80. So this side would be equals to the top side. So let us name them as a variable A over there and A over there. These two sides are equal and they are equals to A. Okay. Now look in this particular triangle, that is this one. Now we can see that the base angles are 20 degree and 20 degree, so the respective sides become equal. The sides are this one and this one, they both are equal, and let us have them as a variable M over there and M over here. Okay, now we can see that in this particular question now we have two variables A and M. So now let us exclude one of them. So what I will do is apply the sine rule in this particular triangle which we took as the isosceles triangle. So first of all, what is the sine rule? Let us see that if there is a nice triangle, any triangle no matter, the angles are A over there, B over there, C over there. The angles are A, B, C, and the sides are X, Y, and Z. Then take the angles A, that is sine of angle A, and opposite to angle A, the side is equals to Y. That ratio would be equals to sine of angle B upon the opposite side of angle B, that is Z, and that would be equals to sine of C, and opposite to angle C is equals to X. So what we have, that sine of the particular angle upon its opposite side, this ratio are unequal. We have this particular thing and it has been called as the sine rule. So we are going to use the same thing in the triangle that we took as the isosceles. Base angles are 20 and 20. So sine of 20 degrees, so I am writing like that way, sine of 20 degree, opposite to angle 20 degree is M. Either we consider this one or that one, both have the opposite side as M, and that is equals to sine of 140 degree upon its opposite side. So opposite to 140 degree is equals to A. The triangle is looking like this way. Okay, this angle is 20, that angle is 20, this angle is 140, this side is M, that side is also equals to M, and the base side is equals to A. So sine of 140 upon A is equals to sine 20 upon M. So okay, over there. Now what we can see, that sine of 140, so 140 is exactly 180 minus 40. Now we have the rule that sine of 180 minus theta equals to sine theta. So according to that rule, we can write 140 first of all as 180 minus 40. Now sine of 180 minus theta, sine theta. So sine of 180 minus 40 becomes sine of 40 degree. Okay. Now again, because of the trigonometric identity, that sine of 2 times the theta is equals to 2 times sine of theta cos of theta. If we will replace theta with 20 degree, we will obtain that sine of 40 degree is equals to 2 times sine of 20 degree into cos of 20 degree. So what we did is just we simplify sine of 140 degree as this particular thing. Now we can see that sine of 20 from both the sides got cancelled out, and some cross multiplications gives me that A is equals to 2 times cos of 20 degree into M. 2 times cos 20 degree is nothing but it's a constant. Yes, we don't know the value, but it is a constant. So what we have is A in terms of M. We have that A is equals to 2 times cos of 20 degree into M. Okay. Now again, moving back to the diagram, if this complete side was equals to A, some part of it was already equals to M. So the remaining part, that is from this point to this point, is going to be the longer minus the shorter. Longer is A, shorter is M. So it is going to be A minus M. Now look in this particular triangle. Yes, let this side, the base one, I am just removing it. Yes, let this side be equals to K. Okay. Now in this particular triangle, that is this one, I am just redrawing this triangle on the other side so it's clear. So the triangle is looking like this, and this way. This angle over here is equals to X. This side we just considered as K. This angle is 10, and this side is equals to A minus M. You can have a look in this also. The 10 degree, the X, the opposite side K, and this opposite side as A minus M. So what we will do is apply the sine rule in this particular triangle again. So sine of X degree upon its opposite, so opposite to angle X is A minus M. So sine of X upon A minus M is equals to sine of 10 degree. Opposite to sine of 10 is, means opposite to angle 10 degree is what? It's K. Now we have the value of a in terms of m, that is a is equals to 2 times cos of 20 degree into m. So this a particularly over here would be replaced with this value. So sine of x upon 2 times cos of 20 degree into m minus m. So we can take m common from here. So taken m common inside the bracket, it will remain 2 times cos of 20 degree minus 1, and that is equals to sine of 10 degree upon k. Now I will shift m over there, sine of 10 degree over here. So what we can have is a ratio that sine of x upon sine of 10 into 2 times cos of, let it be clear, 2 times cos of 20 degree minus 1 is equals to m upon k. So we have this particular ratio that sine of x upon sine of 10 into 2 times cos of 20 minus 1 is equals to ratio m upon k. Now we will again bring the same ratio m upon k by applying the sine rule in another triangle, and we will compare this thing. If you watch my videos, you know my strategy. Now we will apply the sine rule in this particular triangle. So I am just drawing this particular triangle also somewhere over here. So this triangle is looking like this, and this side is equals to k. This angle is equals to 20 degree, this side is equals to m, and this whole angle is equals to 30 plus x. You can also have a look that this angle is 30 plus x, the 20 degree, the k side, and the m side. So the same triangle I drew over there. Now we'll apply the sine rule. So sine of 30 plus x, okay, sine of 30 plus x upon its opposite side, that is m, would be equals to sine of 20 degree upon its opposite side, that is k. Now we can again have the ratio of m upon k. So m upon k would be equals to m gone over there, 20 come over here. So we have sine of 30 plus x upon sine of 20 degrees. So this particular sine 20 can be just written in another form, that is 2 times cos of 10 degree into sine of 10 degree. As I showed you this particular identity, sine of 2 theta is equals to 2 times sine theta cos theta. Just replace theta by 10 to get this particular thing. So we have this equation and we already have this equation, and in both we can see that their one of the side is equals to m upon k. So we can compare their other side. So other side of one of them is equals to this, and I'm just bringing this one close to it. So this is equals to sine of x upon sine of 10 into 2 times cos of 20 degree minus 1. I'm not writing that degree sign, you just understand I am telling when. So sine of 10 got cancelled out, we can do cross multiplication. So this multiplied over there, that multiplied over there. So what we will have is 2 times cos of 20 degree into sine of 30 plus x minus sine of 30 plus x is equals to 2 times cos of 10 into sine of x. There was a bracket present over here, so when multiplied with this, it opened up just as the usual bracket. Now we will apply some trigonometric identities. The identity is that 2 times, let me change the color so it looks different. So we have the nice identity that 2 times sine of a into cos of b is equals to sine of addition of this both a plus b plus sine of subtraction of this both angle a minus b. So this is the rule. So we have this particular thing over here, 2 times sine of a cos of b, 2 times sine of a cos of b. So we will just apply this identity in this term and that term. So when we will apply in this, we will have sine of 20 plus 30 plus x, that is 50 plus x, plus sine of 30 plus x minus 20, that is 10 plus x, minus sine of 30 plus x as it is, so minus sine of 30 plus x, and the same identity with this gives me that sine of 10 plus x in the first bracket minus, not minus, plus sine of x minus 10, so sine of x minus 10. Just look in this identity also, it's a minus b and a plus b. So now we can see that this sine of 10 plus x, sine of 10 plus x from the both the side got cancelled out. I can shift sine of 30 plus x as it is negative on that side and bring this on this side. So what we will have is sine of 50 plus x minus sine of x minus 10, and that would be equals to sine of 30 plus x. Okay, now we can just have another trigonometric identity. The other identity we have is this thing, that is sine of a minus sine of b is equals to 2 times sine of a minus b upon 2 into cos of a plus b upon 2. These are the basic identities. If you learn trigonometric, there's nothing any difficult in that, because these are very normal, simple and cool. So we have this particular identity we will apply in this thing, that is sine of 50 plus x minus sine of x minus 10. So we will have 2 times sine of subtraction of these both angles So 50 plus x minus x plus 10 is equals to 60. 60 upon 2 gives me 30. And into cos of addition of these both angles. So 50 plus x minus 10 is equals to 40 plus 2x. 40 plus 2x upon 2 gives me 20 plus x. And that is equals to sine of 30 plus x. Now what I can observe is that sine 30 is having a value that is 1 by 2. And this 2 multiplied with 1 by 2 gives me 1. So what we finally have is that cos of 20 plus x, that is the LHS part, cos of 20 plus x would be equals to sine of 30 plus x. Now what we can observe is that both these angles, that is sine of 30 plus x and 20 plus x, are in the first quadrant, so we can just compare their values. Why I am telling is that because sine of 60 degree is equals to sine of 120 degree. Now as we usually tell, compare the sides and the angles. So we cannot say 60 is equals to 120 because 120 lie in the second quadrant and 60 lie in the first quadrant. We have to either bring both of them in the same quadrant, then and then only we can compare. You can see it over here also and in my next video also. So sine of 30 plus x in the first quadrant and 20 plus x is also in the first quadrant. So as one side is cos, other side is sine, so we have to just bring both of them in the same trigonometric ratio so we can compare the angles, because the angle contains the variable x and that was we have to find. So what we can do is cos of theta can be written as sine of 90 minus theta. So sine of 90 minus the theta present over here is 20 plus x, and that is equals to sine of 30 plus x. Okay, now this thing can be simplified as sine of 70 minus x, and that is equals to sine of 30 plus x. Now as both these angles are in the first quadrant, we can compare them. So 70 minus x is equals to 30 plus x. Now we can see that 40 is equals to 2 times x. We will get that x is equals to 40 upon 2, that is 20 degree, and that's the answer. What we did is applied the sine rule in that particular two. First of all, in the first triangle to get the value of a in terms of m. Then we applied the sine rule in the two triangles, and the key point was that they were having the common base, that is equals to k. That help us to find the value of x, that is 20 degree. So this was my method to solve this particular question. If you have any other method other than this, you can do comment below, or else you can DM me on my Instagram, link is in the description. When someone gives a better solution to the same question and we can show it to your viewers, it spreads the knowledge.